Welcome to springlib.
This is the answer to Chapter 12, problem number 53 from the Smith Organic Chemistry textbook. This problem asks us to consider these three natural product molecules and to determine what would happen if we treat each of them with osmium tetroxide, with ozone followed by zinc and then water. And so these are going to be oxidative cleavage reactions. And each of these is a multi-alkene. And so all that's going to happen is that we're going to cleave these molecules into multiple pieces. Every alkene bond is going to be cleaved. And the result of this oxidative cleavage is going to be carbonyl groups, so aldehydes and ketones. And so what we can do, looking at this first molecule here, A, what we can do is draw a line through each alkene, and that's where the molecule is going to be cut. And then actually, to sort of make this easier, we can look at all of these pieces and try to identify which pieces are the same, because there are a lot of repeats in this molecule. So I'm going to go ahead and label each of these pieces. So there are a lot of B's, one C actually, and then two more B's, and then another piece. Okay, and so there we go. So our products are going to be 2 equivalents of A, 4 equivalents of B, and 1 equivalent of C. And so that is going to look like this. A is going to give us acetone. So 2 equivalents of acetone. The product of B is going to be an aldehyde on one end and a ketone on the other. So that's going to look like this. So that's the product from B there, a 5-carbon long chunk. And there will be 4 equivalents of this molecule. And then from part C, we're going to have a dialdehyde. So, and this is also going to be, or no, not also. This is going to be 4 carbons long. 2, 3, 4. Okay. And so that's the answer to part A. I suppose I should say, again, this will be 1 equivalent because there's just one section C there. Okay, so part 2 of this, or part B of this problem, we can do exactly the same thing. So just draw a line through each of these double bonds. That's what's going to be cleaved. And then just draw these molecules with aldehydes and ketones. And so our first piece is going to give us a 3-carbon section with an aldehyde. So that's from the very first section there. The next 2 pieces are actually going to be identical. 1, 2, 3, 1, 2, 3. So again, these are going to be 3-carbon dialdehydes. So 1, 2, 3. So there will be 2 equivalents of this. Two equivalents. I apologize. I'm experiencing some lag. That's why my writing is not looking so good here. There we go. 2 equivalents of that 3-carbon dialdehyde. And then our last piece is going to be this entire section to the right that ends in this carboxylic acid. So let's see. So it'll end in an aldehyde on the left end. 2, 3, 4, 5, 6, 7, 8, and up to the carboxylic acid. 1, 2, 3, 4, 5, 6, 7, 8, and then up to the carboxylic acid. Okay, and so there's the answer to part B. And then part C, we can treat exactly the same way. So we'll be cutting at all 3 of these double bonds. And that's going to give us 1 equivalent of acetone. Then I'm actually going to draw this with the orientation sort of the same as it is in the starting material here, because it makes it easier. So rather than try to like open this up and draw it as a straight chain, I'm just drawing it in the exact same orientation as it is in the starting material. So this is going to be an aldehyde. And then this will be another aldehyde. Okay, so there's our one piece. And then our last piece is going to look like this. Okay. And so that's the answer to part C of this problem. And so again, the way to approach these 3 molecules is just to sort of draw lines through the double bonds, and then draw each of the pieces of the molecule out, and just make sure that you know that with this oxidative cleavage reaction, you're going to end up with carbonyl groups where you had your double bonds. And so that's the answer. Oh dear. That's the answer to chapter 12, problem 53.